This video explains how to use CRP5 for conversion between mass and volume, and we are starting right now. Hello and welcome to Answering ATPL. The focus of this channel is to provide solutions for EASA ATPL questions and other aviation-related stuff. Let me know, in the comments section below, if you are currently taking ATPL theoretical examination. This video is the fourth video of a series of videos explaining the usage of CRP5 computer face. If this is your first time here, consider subscribing to my channel, and click on the bell icon to get notified when I publish a new video. Amount of fuel required for a flight is calculated in the unit of mass, either kilograms or pounds. Having determined the amount of fuel required for the flight, it is necessary to convert the mass to volume because the fuel operator dispenses the required amount of fuel in volume, using US gallons, imperial gallons or liters. Mass is defined as the quantity of matter which a body contains. Volume is defined as the amount of space that a substance or object occupies. On the screen is a diagram showing the relationship between mass, volume, and temperature. As a conclusion, we can say that when temperature changes, mass remains constant, and volume is changing with temperature. This poses challenges for conversion. We can't convert mass to volume or volume to mass using a fixed ratio. To convert from mass to volume and vice versa, we need specific gravity. Specific gravity, or SG, is defined as a comparison of the heaviness of one substance to that of water. The formula for specific gravity: SG equals density of object divided by density of water. For example, 1 imperial gallon of F-gas has a mass of 7.2 pounds, and 1 imperial gallon of water has a mass of 10 pounds. Thus, the specific gravity of the F-gas equals 7.2 divided by 10 equals 0.72. Now let's take a look how to make the conversion. In order to help you with the conversion, you'll see on screen a handy chart illustrating all the steps needed to change the volume to mass, and mass to volume. On the left-hand column, volume are listed in US gallons, imperial gallons, and liters. And, in the right-hand column, mass is listed in pounds and kilograms. The necessary conversion factors are listed along the appropriate lines. To carry out a conversion using the arrow, multiply the box at the tail of the arrow by the conversion factor, and when moving against the arrow, divide the box at the arrowhead by the conversion factor. The following example will guide you through conversion. We will work through two examples on screen, first using the chart, and later using CRP5. Example 1. Convert 1,000 US gallons of Jet A1 with specific gravity 0.83 into kilograms. To solve example 1, start by dividing 1,000 US gallons by 1.2, this becomes imperial gallons. Now multiply by 4.546 to bring it to liters. And finally, multiply by the SG 0.83 to reach a solution 3,144 kilograms. Example 2. Demonstrate going in the reverse direction, converting kilograms to US gallons. Convert 1,000 kilograms to US gallons with SG 0.83. First, multiply 1,000 kilograms with 2.205 to bring it to pounds. Now divide by 10 and 0.83 respectively to obtain imperial gallons. And finally, multiply by 1.2 to reach the solution of 319 US gallons. Now let's look on how to do the conversion using CRP5. There are two scales on the periphery of the instrument which enable us to convert volume into mass, and vice versa. There are label SP.G which stand for specific gravity. The first scale is used to convert pounds of fuel at various specific gravity to imperial gallons, US gallons, and liters, and vice versa. This scale can be identified by red letters LBS adjacent to it. The other scale is used to convert kilograms of fuel at various specific gravity to imperial gallons, US gallons, and liters, and vice versa. This scale can be identified by red letters KGS adjacent to it. Now let's rework our previous example to understand how this function works. Example 1. Convert 1,000 US gallons of Jet A1 with specific gravity of 0.83 into kilograms. As any other operation using CRP5, the first step is to approximate the answer. From the previous video, we know that US gallons and imperial gallons have roughly similar magnitude. Thus, we can assume that 1,000 US gal is approximately equal to 1,000 imperial gallons. Round up specific gravity to 0.8. 1,000 imperial gallons times 10 times 0.8 is equal to 8,000 pounds. Since 1 kilogram is approximately equal to 2 pounds, 8,000 pounds are approximately equal to 4,000 kilograms. Now that we have the approximation, we can now use CRP5 to get the answer. Locate US.gal marker. Align the cursor with US.gal marker. Align the 10 index on the inner scale with the cursor to represent 1,000 US gallons. Align cursor to 0.83 on SB.G marker near KGS marker. Read the answer on the inner scale. 31.4. Our approximate value is in the region of 1,000. Our final answer should be 1,000 US gallons at specific gravity of 0.83 equals 3,140 kilograms. Let's use the same example to find the mass in pounds. Ensuring the scale are in their relative position, move the cursor to align it with 0.83 on pounds SP.G scale. Read the answer on the inner scale. 69.2. Our approximate value tells us the final answer is 1,000 US gallons at 0.83 specific gravity equal to 6,920 pounds. Now let's look at example 2. Convert 1,000 kilograms to US gallons at specific gravity 0.83. First step, approximation. 1 kilogram is roughly 2 pounds. Thus, 1,000 kilograms is roughly 2,000 pounds. Round up specific gravity at 0.8, this means 1 imperial gallon equals 8 pounds. We take it as 10 pounds. 2,000 pounds divided by 10 equals 200 imperial gallons. Since imperial gallons and US gallons have roughly the same magnitude, we can say that 200 imperial gallons are approximately 200 US gallons. Now that we have the approximate, we can proceed to step 2, using CRP5 to get the answer. First, locate KGS marker. Align cursor to specific gravity 0.83 near KGS marker. Align the 10 index on the inner scale to the cursor to represent 1,000 kilograms. Align cursor with US.gal marker. Read the answer on the inner scale. 31.9. Thus, our final answer will be 1,000 kilograms at specific gravity 0.83 is equal to 319 US gallons. By using the same procedure, we can also find the value for imperial gallons. Just align the cursor to imp.gal marker. And, read the answer from the inner scale. 26.58. From our approximation, we know the correct value is 265.8 imperial gallons. In the next video in these videos series, we will discuss on time, speed, and distance. If you want to learn more about ATPL or aviation, start now by hitting the round subscribe icons. Also, if you have any questions or comments about ATPL or aviation-related problems, you can leave them in the comments section. Thank you so much for watching. I'll see you next time.